Hey guys, happy Tuesday morning. This is my third attempt at a lecture video, and I'm going to try to talk about briefly our assignment last week, the triangle congruence. You guys seem to have a lot of problems with that. I only got a couple questions, so I'm going to go over just a couple questions I got from that, but overall, you guys did really well reviewing and remembering all of the rules about congruent triangles. And then secondly, I want to talk about the notes that I assigned for you guys to read and review this week. So you're reading along with the notes and you're going along with the examples that are provided and just getting your bearings, if you will, on the equations of a circle. And then that will be the last new material. So kind of excited because circles is a really tough chapter. I don't hate it. I like the chapter on circles. It's one of my favorite chapters, but it is, the chapter goes really far into circles. Your FSA would have had a lot of circle material on it. You can still access that on your My HRW app to see your textbook. It has lessons and activities for all the sections. I believe there's 7, maybe 8, I think 7 sections. Or you can go to Study Island, and there's a whole unit on circles on Study Island. So you're welcome to explore that whole chapter. But what I've decided, and I've thought about it, and what I've decided is that it's too difficult of a chapter to expect you to learn at home on your own. If I had some more one-on-one time with you guys, I would do that. But the way things are right now, the way that all of my 125 students don't have the same internet speed. My internet speed, I've learned, is a lot slower than a lot of my colleagues. So I don't want to frustrate you guys and put you out and to where you're not able to all learn at the same speed. So I picked out the 2 sections that were the most important from the chapter to present to you. And they are the sections that you're going to be using the most going forward with math, whatever class you take next, whether it be maybe you're graduating and you're going to take college algebra someday, or maybe next year you're taking algebra 2 or liberal arts 2, which is basically the same thing as algebra 2. They just don't go through as much material throughout the year, but it's the same type of material. So anyway, you will take these, especially this section I'm going to go over today. You will use this 100% in your next level of algebra. And then briefly, next week I want to do more. I want to do another cumulative review of what we learned this year, more of a review of our second semester of geometry. We'll talk briefly about that next week. And then for May, since we learned we are doing distance learning in May, we will continue to review, not a difficult review, but a cumulative review of geometry. And I will focus on getting you ready for algebra next year. Lucky for you guys, I taught algebra 2 at the high school last year, so I know exactly what curriculum you'll be given next year when you go into your next math at the high school. So I'll do a little bit of prereq review material, so the stuff that you'll need to know when you go into algebra. And they do spend a good month reviewing algebra 1. They're not going to expect you to start learning right off the bat or expect you to remember everything, because we know that you guys had a whole year of geometry where you didn't use algebra heavily. So you did use it quite a bit, but not at the level that you were used to using algebra. So you will start next year with a lengthy review of algebra 1. Okay, so anyway, starting with just reviewing from what the assignment was last week, the triangle congruence, knowing your theorems about how to prove that triangles are congruent and how to use those theorems to help solve missing parts of triangles, whether it's angle measures or side length. So it was 20 questions, and you were supposed to go back and draw the correct answer on the grid of numbers. So I appreciate those of you who were able to turn it in. If you weren't able to turn it in and I saw that you viewed it, I still gave you completion points because not all of us were able to upload it. A lot of us had problems, but I appreciate you trying. I know this can be really frustrating. I've had problems too, but anyway. Okay, so the ones I got questions on were just a little tricky. They weren't hard, they tried to trick you. So number 3 says, and if you want to pause it to pull up last week's congruent triangle review. Okay, number 3 said, how can we classify this triangle? Let me see if you can see it. Let me turn the brightness down real quick. Okay, it was number 3. So that big obtuse triangle right there. How can we classify it? So yes, it has to have one obtuse angle to be classified as obtuse, so it is obtuse. The measures of the sides are 7, 6, and 12 units long. Those are all 3 different measures, so it will be scaling and obtuse. And then number 5, how can we classify this triangle? So if you look at number 5, he is a little equilateral triangle. Now the tricky part about that is over here, the red stars option, that was the right answer as you could see on the key, and that's because the definition of an isosceles triangle is just a triangle that has 2 congruent sides. Does this have 2 congruent sides? Yes, it does. So it could be considered isosceles, but the best term to give it, the most accurate term to give it, is equilateral. So it is isosceles by definition, it is equilateral, and it is acute. It's also equiangular, right? All right, number 10 was one I had a question on. This is reviewing our triangle. They called it angle sum theorem. We called it triangle sum theorem. Third angle theorem and exterior angle theorem. All right, so number 10 says, which theorem would be most useful to find the numbered angles? That word most, we know by now, is tricky. That means there's probably more than one right answer, but one of them is most correct. So there are 2 answers here that I consider correct, and it would be angle sum theorem and exterior angle theorem. They're saying, if you can tell by the answer key, that the exterior angle theorem is the most accurate. And I posted a little cut and paste notes that I put into the assignment folder to help you review these 3 theorems because I knew we hadn't talked about them in a while. And those notes remind you that the exterior angle theorem is when you take the exterior angle of the 150 and you know that its measure is going to equal the sum of the 2 remote interior angles. The remote meaning furthest away. So we know that angle 1 plus angle 2 will equal 150 degrees by the exterior angle theorem. And they're saying that is the most accurate information you can pull from that. We can't solve those angle measures, but we can write ourselves a little equation. Also, the one that you could help and get some information to prove from is the triangle sum theorem, which would be the blue fish. That one, what you would do is you would say, okay, I know because of supplementary angles, right here, this angle of 150 tells me that that interior adjacent acute angle has to be what? 30 degrees, right? So I know that angle 1 plus angle 2 plus 30 degrees equals, how many degrees are in a triangle? 180. And that is a little equation I wrote myself using the triangle sum theorem, the fact that all 3 interior angles of a triangle have to equal 180. Perfect. And then the other one, I think I only had one other question, and it was on number 20. That was another tricky one. They tried to trick you with terminology. Number 20, the last question said, a triangle with side lengths 4, 6, and 12 is congruent to a triangle with side lengths 8, 12, and 24 by, the key word on number 20 that's tricky is the word congruent. So they've set us up for a really good example of similar triangles. Those 2 triangles are similar triangles. They're the same exact ratio of sides, but they're not congruent. Congruent means equal in measure, right? So these are not congruent triangles. Obviously their measures are not equal. They're similar, but they're not equal. Okay, that's all the questions I had. Remember, if you guys have any questions on anything that any of the tasks I give you, to just message me or comment on the thread. If you have a question, I can almost guarantee somebody else does too, so. Okay, moving on to the PowerPoint notes that I assigned for you to read this week. So if you want to pull those up, please. Okay, objectives. I'm starting with slide 1. if you would like to follow along. If not, some of us, you should be able to, through ClassLink, open up, you know this by now, your 365 and get to PowerPoint. But if we're having issues with that, just follow along with what I'm saying. I'm going to try to go over all the slides. But yeah, so I shortened this PowerPoint down to 14 slides. And our objectives are to write equations and graph circles in the coordinate plane, and to use the equations and graphs of that circle to solve problems. What I would love for us to be able to do after this video is to be able to read equations of circles and easily graph that equation. Anything after that, not super worried about right now. Your Algebra 2 teacher can help you with that. So Algebra 2, or your next level of algebra, you will do a ton of graphing. So it's going to be a nice change of pace for you, because you will not have to prove or derive equations anymore. You will simply just be procedurally working, plotting, graphing, solving, maybe doing some word problems. So it sounds difficult, but it's really not. Once you practice it and get the hang of it, it's not that bad. You'll be working with several different, I think I went through a dozen different functions and equations when I taught it, and you might go through more depending on what class you're in. This is one of them. So knowing how to read the equation and just start graphing equations is a good thing. Okay, so equation of a circle is, this is geometry, so we're going to derive the equation. Like I said, you don't have to worry about it in the future, but we will easily be able to derive this equation from the distance formula that we've worked with so much this year. So if you remember the distance formula, I'm gonna use blue. All right, slide 2 is where I am now. Distance formula. Okay, so your distance formula helps you solve the distance between 2 points, 2 coordinates on a plane. We know that. We've used it 100 times. Now, don't you agree that the radius of a circle is the distance between 2 points? So what they're doing is they're saying, I'm going to take the distance formula, and instead of wanting to know the distance between the 2 points, I'm going to call that my radius. So they would replace the D with an R. And then instead of calling this point 1 and this point 2, point 1 and point 2, they've called it the center of the circle at HK, and then any point on the circle itself. So don't you agree that any single point on this circle is the same distance to the radius? Yes. So that is how they're able to just say XY for any point on the circle. The center is always going to be called HK, and we care about the distance between those 2 points, or the radius. Now the last point of going from the distance formula to the equation of a circle is, instead of leaving it as a big square root to make it look nicer and to make it easier to do the arithmetic with, they've simply squared both sides, which gets rid of our radical sign, or our square root. So we end up with, we swapped our D for an R, we have radius squared equals, and then we don't have a second xy, we have an hk, so now we have x minus h squared plus y minus k squared. So now that is how they got their equation of a circle. Okay, so I drew this here to remind you, for those of us who are more visual or tactile learners, this is your center of your circle, okay, HK, and this is any point on the circle itself, XY. And using these, we can find the radius, or we know from Algebra 1, we only need 2 of these 3 pieces of information to solve a missing piece. So if I know my radius and I know a point on my circle, I can find the center. Or if I know the center and I know my radius length, I can solve for the point on the circle, right? So that's what they're going to have you do through the slides, is just practice solving for the one missing piece, whether it's HK, R, or XY. Okay, so understanding where the formula kind of came from a little bit, or the equation, sorry, what formula it came from, helps. Remembering that R represents radius and that HK represents the center of the circle, that's a big help. All right, I'm going to move over to slide 4, example 1a, writing the equation of a circle. Write the equation of each circle, circle J, with center J, 2, 2, and radius of 4. So the center of the circle J is at 2, 2, and the radius is 4. So my HK, I'm going to use red. The center of my circle is HK, so I just wrote HK above that point. My H is 2, my K is 2. My radius is 4, that's the given information. My job is to simply plug that into the equation of a circle and simplify, okay? So now I'm going to place my 2 here, this 2 here, this 4 here. And is there anything I can simplify? Yes, I can simplify this right here. 4 squared is 16. Perfect. Okay, so now you say, well, that still looks really messy and confusing, and that cannot be the solution. That is the solution. This is something that you could type into. You could go to your graph setting, you could type this equation in, and it will graph your circle. And that is your answer, and that's as far as you would need to go. We're not solving a real world situation here. What we're doing is we're saying, if I want to communicate this circle to an engineer or to a mathematician, I'm going to email them this formula, and they're going to know exactly what circle I'm talking about. So that's the end of the problem. All right, write the equation of each circle. I'm on slide 5 now. Now we have circle K passing through the center of circle J. Nope. Circle K, it passes through J at 6, 4, and has a center of 1, -8. So we have to plug in everything? Distance formula. We don't want to use the distance formula. We have to solve. Oh, we're solving for the radius. Oh, that's fun. I don't remember this one. Okay, are you ready for me to erase? Okay, so the 2 pieces of information that this problem were on slide 4. I really don't have room to write this whole problem down, but the 2 pieces of information that they've given us in the bold black here is they've given us one of the points that the circle passes through, and they've given us the center of the circle. So those are the 2 pieces they've given us. The one missing piece is the radius. So they want us to solve for the radius. Once we've solved for the radius, they want us to write the equation of the circle. Okay. So let's do one of these. I'm going to write down just the couple pieces of information they gave us. Circle K passes through a point, J, so we're going to call this J, for example, and it is at 6, 4, so I'm going to call that my X and my Y, and has a center of K, which is at 1, -8, and those are going to be my H and K values. So let's go ahead and plug those in and solve for the radius so that we do know the actual equation to communicate to people. So I'm going to plug in 6 here, minus my H, which is 1, squared, plus my Y, minus my -8. So if I subtract a -8, I get a positive, right? All right, so let's now just simplify to arithmetic. And we're going to get 5 squared plus 12 squared. 5 squared is 25. 12 squared is 144. 144 plus 25 is 169. So my r squared equals 169. I want to square root. My radius is 13. Okay, now to write the equation of the circle. So if I'm communicating to somebody where this circle would be graphed, I'm not going to give them one specific point that the circle passes through. I'm going to give them the center of the circle and the radius. And then that's going to graph the circle. Okay, so the one point that the circle passed through, J, helped us solve for the equation of the circle, but it doesn't need to be involved in the equation of the circle to communicate to people. That would just communicate one point of the circle to them. So we're going to get rid of that J information, and we're going to use the center of the circle and the radius of 13, and we're going to plug radius and HK into the formula for the equation of a circle. All right, so r squared, 13 squared, equals x minus h squared plus y minus k, which is a positive, because if I subtract a negative 8, I get a positive 8. All right, so let's just simplify. We don't want to tell somebody this. That's going to make us look silly. We haven't simplified it yet. So what is 13 squared? 13 squared is 169. And that is the equation of that circle. So if I typed this equation into my calculator, I would get the same circle every single time. So that is how to communicate that. Very good. Okay, so I think we can work through the next couple examples. I'm going to move to slide number 8. Okay, so there's two ways to do this. But the second objective is they want to, if you're given the equation of a circle, they want you to be able to graph the circle by using a table or identifying its center and radius. I can tell you right now that identifying the center and radius is way easier when graphing, but let's go through one example of using a table, because you will be making and using a lot of tables next year. I know I sound like a parrot, but okay, so let's do slide number 9, example 2A, graphing a circle. I'm going to go ahead and erase this so I have more room. Okay, so they want us to graph, in example 2A, they want us to graph x squared plus y squared equals 16. So yes, that is the proper format for the equation of that circle. Someone gave that to me, and now I'm going to graph it. All right, so make a table of values. Since the radius, so my radius my r squared, because remember the equation of a circle is r squared equals, so r squared is 16. To solve for r, I have square rooted both sides. R is plus or minus 4. So my radius is going to go 4 units to the right on the x-axis and 4 units to the left on the y-axis. That's why we're doing plus and minus 4 now with circles. All right, so since the radius is plus or minus 4, use the values for the x values. So now we're going to do one example of the table method. You'll notice on your slides they use horizontal tables. That drives me nuts. We're going to use vertical tables. So x, y. Now, my circle has a radius, has a diameter of 8, but a radius of 4 in each direction. So if I go higher than 4 on my x table, or lower than -4, I'm going to be off the circle and I'm going to get errors. I don't care about that right now. Later, higher up in Algebra 2 and in Calculus, we do care about that zone, and that's when imaginary numbers come into play. But right now, we're graphing a real, tangible 2D circle. We're not worried about imaginary zones. We want to stay in the circle, on the circle. So that tells me my table needs to go from -4 to +4. So I'm going to do -4. They did -4, -3, -2, and 0. I'm going to do -4, -2, 0, +2, +4. Okay, so I have pulled these x values out of my thinking cap. Okay, I get to kind of decide. I get to have a little say in what numbers. I could have done -3.9 if I wanted to. I could have done -1. I could have done 1.5. But I chose to do these because they're symmetrical and even, and that looks good to me. All right, so now I'm simply going to plug in this x value into my given equation and solve for the one missing piece then, which is y. So when x is -4, let's plug it in and see what happens. What will my y be? Now I have set up a little Algebra 1 problem for myself. You use a lot of these in algebra. All right, so, oh, have I said that yet? All right, so what's -4 squared? -4 times -4 is a +16. Plus y squared equals 16. What is my y going to be? I'm going to move this 16 over. Y squared equals 0. 16 minus 16 is 0. Square root y equals 0. Square root of 0 is 0. 0 times 0 is 0. So when my x is -4, my y is 0. What happens when my x is now a -2? Plug that in into the equation of the circle and see what happens. So on this circle, when my x coordinate is at -2, where will my y coordinate be? It will be at, what's -2 times -2 is a +4. Move your 4 over. Y squared is 12. Last step. Square root both sides. Get out my calculator because it's algebra and I'm allowed to use a calculator in algebra 2 most of the time. All right, second square root 12. Square root of 12 is about 3.5-ish. So y is going to equal plus or minus 3.5. And I will show you how to graph those plus and minuses in just a second. Okay, so if you plug in your 0 here, for the sake of time, I'm going to go ahead and fill in the rest of the table, but you would do it this way for every single coordinate, which is why people don't like graphing, but it's not bad. For those of us who like arithmetic especially. All right, so when I plug a 0 in for my x, my PowerPoint is telling me I'm going to get a plus or minus 4. When I plug in a 2 for my x, my PowerPoint tells me I'm going to get a plus or minus 2.6. When I plug in a 4 for x, my PowerPoint tells me I'm going to get a 0 for y. All right, so let's go ahead and... Hi, Brody. Just checked in on Remind. Okay. Let's plot. So I see here that my x's need to go to 4, -4. My y's need to go plus or minus 4. That makes sense, doesn't it? That the radius would be 4 both directions. All right, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I got my y-axis and my x-axis. Okay, so when my x is at -4, so I'm going to go left 4, my y is at 0. When my x is at -2, my y's, because it's a circle, my y's, both of my y's are going to be positive 3.5 and negative 3.5. So I'm going to go -2 on my x-axis, and I'm going to go up 3.5 on my y. And I'm also going to go down 3.5 for my y. -2, down 3.5. Perfect. When my x is at 0, my y's are at positive 4 and -4. So really I have 2 points here. I have 0, 4, and I have 0, -4. Does that make sense? So I have 0, positive 4. I have 0, -4. Now when I'm at 2 for x, I go up 2.6 and down 2.6. When I'm at 4 on my x-axis, my y is at 0. Okay, so now to graph circles or arcs, which we weren't able to get into, anything that's curved. I don't want to say it again, but you'll see a lot of curved things. You just loosely, like I know a circle has curved lines, so I'm not going to go do. I'm going to loosely connect the dots with a little bit of an arc to them. And we all know that Mr. X isn't very good at drawing things, but this is supposed to be a circle. It's supposed to be a circle. On a scale of 1 to 10, I give that circle about a 4, which is the length of its radius. Okay, that's the long way of graphing a circle, but since we're still in geometry, we're not in Algebra 2, it can be easier than that, and I'm going to show you how. So, same equation, easier way of graphing. Can't guarantee it's going to look any better when I graph it, but it's going to be easier. Alright, so we've already solved that our radius is 4, same thing. Now, where is my h and k? There's nothing, right? My center is at 0. My h and k are 0. So the center of this circle is at 0, 0. And I'll show you another example where we pull an h and k. So my center is at 0, 0. And my radius goes 4 in every direction on the x and y axis from that center. So I know that these are 4 easy to find points on my circle. Now if I'm good at sketching and I can connect those with a nice smooth arc, hopefully you're better than I am, that's all you have to do to graph your circle. So, okay, this is also where graph paper comes in handy, because when we try to freehand x and y axes like this, for me, my y always ends up being kind of squatty and my x ends up being, anyway, graph paper helps with this. So yeah, that's another way to graph. So let's do another example of graphing by just reading the r and h and k off of your equation. Which one do I should have figured this out sooner? Which one do I want to do? Let's just do the next slide, slide 10. Okay, so it's example 2b, graphing a circle. They want us to graph. This is the equation of the circle they want us to graph. Okay, what are my h and k values? So I see a +4, so I know that when I was given that k value, it had to be a -4, because if you subtract a negative, you get positive, right? So my h is a 3, and my k is a -4. What's my radius? Well, my r squared is 9. So let's square root both sides. My radius is ±3. So from the center, my radius goes right 3 or left 3, up 3 or down 3. Okay, so let's plot. My center is going to be at 3, -4. So 3, -4 is the center of my circle, right here. Once again, graph paper would help with this. So I'm going to go up 3, down 3, right 3, left 3 to graph this circle with a radius of 3. The radius is the same distance all the way around. So let's go ahead and graph the radius. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so I know those are 4 points that are on my circle. My dog just opened the door. Can you go shut the door, Susie? Can you go shut the door back? No? You guys want to see my dog real quick? This is my old dog. Come here, Sissy. Oh, she's big. This is Sissy. We also adopted a new puppy because that's what everybody's doing during quarantine. And she's crazy, but she's really cute. All right, so I'm going to go ahead and just loosely connect those 4 points that I easily found, right? And that's how your circle would look. So this equation makes this circle every time. Perfect. All right, so the rest of the slides are just more examples of what we just did. Slide 13 and 14 are the lesson quiz. I don't teach off these PowerPoints in class ever, but they're not bad PowerPoints. So 1, 2, 3, and 4, lesson quiz part 1 on slide 13. They give you circle L with a center at -5, -6, and a radius of 9. So let me do that one with you guys real quick. So we are on lesson quiz. Let me shut that door that my dog opened real quick. You can hear my husband in there trying to train the puppy. She's doing really well. She's really smart. All right, number 1, circle L with center L. So we have circle L. The center is at -5, -6, which tells me my H and my K. My radius is 9. So R squared equals X minus H squared plus Y minus K squared. So I'm just simply going to plug in my H and my K and my R. So my R is 9. I have 9 squared equals X minus a -5. So if you subtract a -5, you get a positive. Plus Y minus -6. So I'm going to add the 6. And then the last thing to do is to simplify, because we don't turn in work or answers that aren't simplified. So 9 squared is, 9 times 9 is 81. And then the rest of it, we cannot simplify. We want it to stay in that form. That is the universal form for the equation of a circle. If I communicate that to a professor, an engineer, whoever wants to know it, they want it in that form. Perfect. Okay, 2 is the same thing. I'm going to let you do that one on your own and check your work. 3 and 4 are graphing the equation. You can use the table method of graphing if you'd like. It's good practice with your arithmetic as well. Double check your answers. If you're graphing your answers and it looks really weird, not like Miss Reich's weird, but like it looks like a star or a parallelogram or something, that means obviously you probably messed up with your arithmetic when you were solving for your y coordinates. Okay, so let's do number 4 together real quick. They want us to graph this equation. All right, so I'm going to pull my center off of this equation and my radius. So my center, this is my H and my K value. So my H is at -2. My K, the original equation is Y minus K. So my K must be a -4. Oh, what did I do there? Got ahead of myself. So this is my H, this is my K. My R squared equals 16. So what is the value of my radius? It is plus or minus 4. All right, so now I can graph. Oh, Sissy, that's going to scare the students. You're a good girl. Okay. Okay. 1, 2, 3, 4. Okay, so I need to plot my center at 2, -4. And then I know my radius is going to go up 4, down 4, left 4, right 4. So let's go 1, 2. We need to go 1, 2. We need to go 1, 2, 3, 4. Okay, so I'm going to go right 4. 1, 2, 3, 4. I'm going to go left 4. Up 4. from my center and down 4. And then I'm going to imperfectly sketch. That's it. We've graphed it. All right, so if you could do 2 and 3 on your own and check your answers, that would be great. If you have any questions, please feel free to message me on Remind or in the chat on Teams, or to reply where I posted this. But let's see, miss you guys. Hope you're all adjusting and making the best of your time and situations. If you need anything at all, just message me and I will do as much as I can to help you, okay? Miss you guys. Bye.